Hello, let me go over the solution for homework number two. Uh, the homework number two, remember we cover the probability and probability distribution. So the first problem, what I ask for, uh, it was the multiplication rule. So four letter, we have the license plate, and I ask you if you have four letters with two-digit number, what would be how many ways you would have. So basically, you have 26 letter and 10 numbers. So we have four letters, so it would be 26 times 26 times 26 times 26 times 10 times 10. That is the number of ways you can get license plate. So if we change it to two letter with four digit, basically you're changing the number of multiplication for letter, which become 26 times 26. Now you have four number, so the number would be 676,760,000 ways. So that was very simple. Question two, I ask you to uh, we have breastfeeding and breast cancer information. We suppose pick up a woman. What is the probability this woman will breastfeed? So if you look at the breastfeed column row, is 1400 total. You have 100 plus for 1300. They are the number of breastfeed. That's your event M, which is probability E. Remember M over N. 1400 over the total sample is 2500 is 0.56. What we call this probability is marginal probability. Now, what is the probability woman who did not breastfeed and had breast cancer? So it's 400, that intersection over 2500 is 0.16. Again, that probability called joint probability. What is the probability of women no breast cancer given no breastfeeding? So again, you're looking at the conditional probability. So if you look at no breastfeeding, that's your no breastfeeding 1100, and and no breast cancer is 700.64 is conditional probability. And suppose we pick up woman, we want to know if she had breast cancer or breastfeed or both. So you have two events. First event is your first event is we define as breast cancer. Second event is when she breastfed, and so for two events you have the additional rule. So probability A plus B minus A probability. So basically you find probability of breast cancer, probability breastfeed, and then the intersection breast cancer and breastfeeding, which is they have 100 who breast cancer and breastfeed, you have to subtract that. And that is additional rule. And how many marginal probability do we have for this table is the number is 4 because you have two rows, two columns. Question three was we have this HIV and this HIV actually and the test result. What is the sensitivity? Remember, this is your A, B, C, D. A over A plus C is 980 over 1300 is 0.75. That means you have the ability of test to single out people who have HIV. What is the specificity is your D, the true negative 2260 over 2400, 0.94. That means that much 0.94 you have ability of test to classify who do not have the HIV as negative. What is the false positive and false negative? False positive is 1 minus specificity. False negative is 1 minus sensitivity. So 0.25 and 0.06 is the correct answer for that. And what is the positive predicted value and negative predicted value? Again, A over A plus B is 980 over 1120 is 0.875, and D over C plus D is also 0.875, which is both of 0.88. And this one, positive predictive, is the probability of HIV among patients with the positive test, and negative predictive is basically the probability of no HIV among patients with negative test. So these are a screening test, and it's very important in hospital or clinical. You wanted to know what is the sensitivity and specificity and a special test you're doing, and because that gives you some idea in terms of false positive and false negative at the same time. Question 4 is binomial. We have 0.2 a smoker for adult, and we have 10. So what is the probability no smoker? If I use the formula probability x equals 0, 10 choose 0, and calculate that, get 0.1074. From the binomial table, again, you find 0.2, and for an N10, you have to find N10 here. So N10 is here. So 0.2 here is 0.2. That is the value you find from table, exactly the same value. And what is the mean? Again, N times P, N times 10 times 0.2 is 2. What is the variance? 10 times 0.2 times 1 minus 0.2 is 1.6. Question 5, it was by Poisson. Again, the binomial distribution, we have 0.96 passing NCLEX and 50. Basically, the mean would be 50 times 0.96, 48. Question 6 was Poisson distribution. For Poisson distribution, again, we have one parameter, which is the average of event happen. It was 4 falling in hospital. I asked you what is exactly 5 fall. So if you replace in the formula, you can get 0.16, and also you can find it from table. Again, here I put it from the table. Remember, you have to use, so we have 4, the average of 4. First you find the lambda, and I ask you average 5, so you have to subtract these two values from each other. Some of the table, this table actually give you the value, but some of the table you have to subtract it. So basically, there are 2 ways you can calculate that. Given that was the Poisson distribution again. Now we come to continuous. The Poisson and binomial was a discrete distribution for categorical variable. Now we are getting to continuous variable. So we have normal distribution. Find the following area. Area P Z less than 0.05. Again, if you look at the Z table, which we were looking, 1.5, you have to look at 1.5, and this is the 0.9332 is the correct answer. So Z 1.96, basically 0.975 minus it gives you 0.95. So you find this value from Z table. Again, 1.96 is here, 1.96, and then negative 1.96, negative 1.96 again is here. So you subtract these two values, you get the area. So that's you get. Now you have the area. What is the value? If you look at the table 0.90, I put 1.285, the exact value, because if you look at the table 0.90, you have to find the body in body 0.90. So 0.90 is somewhere between these two values actually. So you can average 1.28 and 1.29. That's I got. So either one, if you select, is correct. So that was the closest answer. So you could have choose. But if you want to exact, so you have to average those two values because table doesn't show. So that's I explained. So 1.28, the average is 1.285. Now this one again, what you can do, you write it. You know what is the probability z is 0.975. You replace that in the formula, and then you solve this equation. You get one value, which is not the area. You have 0.025. What is the z value? You get negative 1.96. So question 9, we have a normal distribution, 100 pounds, mean of population of mean 100 pounds, and the standard deviation of population is 10. So I ask you, if the value is 90, what would be the area? So you convert x 90 minus 100. So here your 90 minus your mean, which is so less than 90, so you get x minus mu, and then you get the z value, and then find the area, which is 0.1587, which you rounded 0.16. The same way you calculate these two values, 80 minus 130. So you have to find these two values between z negative 2 and 3, basically converted, and you get 0.9759, which is 0.98. Question 10, the distribution. Now we have a sample size 25. You have 100, and the variance 100, which sigma would be a square root of that 10. So between these two values, again, you convert those using this formula, 100 minus 100 over 10 over a square root of 25, and that's give you basically the value between 0 and 2.5. And if you calculate 0, the value is 0.5, and then the 0.993 would be 0.4938, which I rounded to 0.49. And for x bar greater than 96, basically you use the x bar minus x minus mu sigma over square, and to convert to z, you get probability z greater than 2. Then you subtract from 1 to get the left area, and it would be 0.772 or 0.98. So I hope this explanation clarifies some of the questions you have and help you to understand better the material.